In this exercise, let us learn how to model a multi-storied frame, two-dimensional multi-storied frame. Click New, click File Name. So type the file name, let it be multi-storied frame 1. Choose the location, choose units, metric system of units, click Create, click Structure Wizard. The Structure Wizard, select Frame Models, click Bay Frame. Let the length of the frame be, say, 10 meters, height, say 11 meters, width 0, number of bays along length. Let us have 3 bays. And number of bays along height, let's have 4 bays, and number of bays along width 0. Then let us define the bay lengths. Say along the length, say we have it has divided equally into 3.33. So now we will define the bay length. Let the first bay length be 4 meters, second bay be 3, and third bay 3. Click OK. Next we have 4 bays along the height direction. So let the first bay, that is from the ground level, from the footing level to the plinth level, let it be 2 meters. Then the ground floor, say 3 meters, and every floor 3 meters height. We have G plus 2. Click OK. Click Apply. So this is the multi-storied frame which we have developed. Say it has 3 bays along x-axis, 4 bays along y-axis. So this we need to go as per the plan which we have. Then click File, click Merge Model STAADPro Model, click Yes, click OK. Click the front view to see the front view. So click front view. So we very well know that this is the plinth beam level, floor beams. These two are floor beams, and this is the roof beam. So we have ground plus 2 stories. The next step is to give the member properties for the plinth beam, for these floor beams, for the roof beam, and for the columns. So this we need to identify, or we need to mention how the dimensions earlier before working with the STAADPro. So from the plan or from the span and all, we can have the size. So let us keep on adding the sizes which we want to give. So go to properties, click define, click rectangle, say 0.45 by 0.23. Let it be one dimension. Click add. Let us have a beam of dimension 0.38 by 0.23. Add. Then another beam of dimension 0.3 by. Initially we need to write what are the properties which we are going to use. So we can add whatever the properties which we have, which we are going to assign. So click close. So let us select this property 0.45 by 0.23. I'm going to give for these 2 floor beams and for the intermediate columns. So let us select, press Ctrl. I'm going to give this for this beam, this column, this column, this column, this column. So whatever members which belong to this category we can give. So select by pressing Ctrl, click Assign, click Yes. Say this 0.38 by 0.23, I'm going to give for these numbers. This member also earlier, I hope we haven't given. So let's give now. So click assign. Yes. Then we need to give the column properties. Say let the columns of size 0.3 by 0.23. So we need to select all the columns. Let us give the same property to all the columns. So if you want, we have already given these two columns. So the remaining column size to be assigned is the end column. So select the end columns. We are going to give this property. So click assign, click yes. Now if you want to see whether we have assigned all the member properties, go to view, go to 3D rendered view. So here we can see the solid model developed. In case if it shows a line model, then it indicates that we have not assigned the member property. So this is the frame which we have created. Next is support specifications. So go to supports, say create, fixed support, click add, select the support. We're going to give to this support, this support, this support, and to this support. Click assign, click yes. Next is loading. Say let the roof beam will be having only parapet wall load as well the load from slab. Then here it will have the roof live load, floor live load as well the wall weight of wall above this. Therefore, the loads on the floor beams will be more than the loads on the roof beam, and plinth beam will have a load from the wall above it. So let us give load like this. So click load case details, click add, close, then click load case, click add. Say let me add member load of say minus 30 kilonewton per meter acting on the roof slab. Click yes. Then minus 60 acting on the floor beams. Click add. On the plinth beam, let it be minus 25. Click add, close. So we have these three member loads, and these loads need to be calculated before assigning two members. So this need to be calculated with the height of the wall and all from the load calculations. So load calculations will have a separate video how to do the load calculations. So let this load be assigned to the roof members. So press Ctrl, select the roof beams. Click assign to select the beam. Click assign. Click yes. Now we are going to assign this minus 60 to the floor beams. So select only the floor beams. Select only the floor beams. So this is also selected. So just click over it to unselect it. So we are going to give minus 60 over the floor beams. Click assign. Click yes. Then unselect this. Then go to this minus 25. Select the plinth beam. Click assign. Click yes. So if you want to visualize the load, click view loading diagram. It shows only the current loading. If you want to see the entire loading, go to view, display options, assign dialogs, show all labels, click apply. Okay. Now all the loads are visible. We don't see the load values. If you want to see the load values, initially you will be doing the label settings. So I want to see the node numbers, node points, beam numbers, and load values. Click apply, click OK. Now this plinth beam is subjected to a UDL of 25 kilonewton per meter, floor beams subjected to 60 kilonewton per meter, and the roof beam subjected to 30 kilonewton per meter. This is the loading pattern which we are given for this multi-story frame. Next is analysis. So go to analysis commands, perform analysis, print all, add, close. Then next is design. So go to design, select a member, a material as concrete, select the code, current code as IS426, select parameters, bring all the parameters to left side, press Ctrl and select the required parameters, FC, FY main, FY secondary, maximum main, maximum secondary, then minimum main and minimum secondary. Bring to the selected parameter site, click OK. Now before defining the parameters, select all the numbers by window drag or using Control A option. So all the numbers are selected. Go to define parameters. So I'm going to give an M20 grade concrete. So 20,000, click assign, say FY main. I'm going to do 415 grade steel. FY secondary. So all the units are in kilonewton per meter square. Therefore, otherwise Newton per mm square means 450 Newton per mm square. In kilonewton per meter square, we need to multiply by 1000. Click assign. Then maximum main, say let us restrict to 20 mm. Maximum secondary as usual, let us restrict to 12. Minimum main 12 for beams. Click assign. Minimum secondary 8. Assign. Close. Now, these are to be designed as beams and these are to be designed as columns. So first select the beams. So to select the beams, go to select. Here you have option called beam parallel to. So beam parallel to X. All the beams will be selected. Go to commands, design beam. Click assign. Close. Now the columns are to be selected. So select beams parallel to Y. All the columns will be selected. Click commands. These need to be designed as columns. To design column, click assign. Close. Now select everything by pressing Ctrl A or by window drag option. Then go to commands, take off. Click assign. Close. So this completes the pre-processing, that is development of the geometry of this multi-storied frame, giving the member properties which we intend to give or which we have already identified the dimensions which we are planning to give for the column and beam members, and then support specifications, fixed support at the base, and then loading. We need to calculate the loading before giving. So those loads we are given as 30, 60, and 25. And then analysis command and design command. So this completes pre-processing. Next is processing. So go to analysis and design, click run analysis, click save. So we should get analysis successfully completed message so that we have not entered or encountered any errors. Click done. Now we want to see the results. Go to post-processing, click apply, click OK. And maximize this screen. Say if you want to see the bending diagram, click MZ. If you want to see the values, click annotate, click beam results, ends, maximum, midpoint, shear ends, maximum, midpoint, click annotate, click OK. Now if you want to see the shear force diagram, close the bending diagram and click Y. Now if you want to see the results like beam design results, we can do two ways. That is, one is you select the beams cursor and click on anything. Say if you want to have the roof beam details, click on the roof beam and click concrete design. So 216 is required at the top and 312 is required at the bottom. 8 mm dia 250 center is the shear reinforcement. Likewise, you can click on anything. Say if I'm interested in this column, click on this column, go to the concrete design. Column dimension is 0.3 by 0.45. 8 numbers of 12 mm is required. We can change the diameter. Say if you want to provide 16 mm diameter, you can change accordingly the numbers by calculating. And if you want to see the results as a whole, then go to utilities, go to analysis output, wherein you will be having all the design values of beams as well columns. So if you click beam, this will give the design details of if I maximize, so you can see the beam. Say beam number 1, it is M20 grade concrete and Fe415 main steel and Fe415 secondary steel. Length is 4 meters. Say the reinforcement at the top and reinforcement at the bottom. And this is the number of bars required. So for every beams and columns, you will be having the details here. Similarly, if you want to see the column details, click on column. So column number will be given and the reinforcement required for every column will be given. And at the end, say if you go to the end, you can see the quantity of concrete, volume of concrete required for this multi-storied frame, say 7.4 cubic meter. Accordingly, we can calculate the cement and other aggregates required for making this concrete. Similarly, 8 mm how much steel is required, 12 mm how much steel is required, and 16 mm how much steel is required. So this will help us procuring the steel for the project. So this completes this exercise.